Imagine this. You visit your favorite shopping website. You trust it. You've been using it for years. You log in, browse a few products, add something to your cart. Everything looks completely normal. Then, somewhere across the world, a hacker smiles. Because your session, your login, and maybe even your personal information has just landed on their computer. Not because you downloaded malware, not because you clicked a phishing email, not because your password was weak. The mobile app itself or its website betrayed you. This is cross-site scripting. Welcome to the Chauhan Explains, where we turn complex cyber attacks into stories anyone can understand. Today, we're exploring one of the most dangerous vulnerabilities on the internet, XSS. Meet Rahul. Rahul loves reading product reviews before buying anything. One day, he visits an online shopping mobile application or its website. Everything looks genuine. He scrolls down. Someone has written 5 stars. Amazing product. Highly recommended. Looks normal. Except that review isn't just text. Hidden inside it is a tiny piece of JavaScript written by a hacker. Rahul never sees it. The website never blocks it. The browser happily executes it. And suddenly, that tiny script begins working. Not on the hacker's computer, on Rahul's. Here's the scary part. The hacker never hacked Rahul directly. Instead, they hacked the website first. They found a place where users could enter text, a review, a comment, a search box, a feedback form. Instead of entering normal text, they inserted malicious JavaScript. The vulnerable website stored that code and later sent it to every visitor. Rahul's browser thought this code came from a trusted website, so it executed it automatically. The browser couldn't tell the difference between the website's code and the hacker's code. That's exactly what cross-site scripting is. The website unknowingly becomes the attacker's delivery system. Imagine you receive a birthday cake from your best friend. It looks delicious. You trust your friend, so you eat it. But hidden inside the cake, someone has placed poison. You weren't betrayed by the delivery person. You weren't tricked by a stranger. You trusted the cake because it came from someone you knew. That's XSS. The website is the cake. The malicious JavaScript is the poison. And your browser consumes it because it trusts the website. A successful SSS attack can steal session cookies, log every key you type, read information displayed on the page, redirect you to fake login pages, change what you see, display fake payment requests, perform actions on your behalf. One tiny script can compromise thousands of users. There are 3 main types. Stored XSS. The malicious code is saved on the website. Every visitor becomes a victim. Reflected XSS. The malicious code is reflected back immediately through a crafted link, usually used in phishing attacks. DOM-based XSS. The vulnerability exists entirely inside your browser. JavaScript on the page manipulates the web page in an unsafe way. Can XSS affect mobile apps? Here's a question many people ask.
If I use a mobile app instead of a browser, am I safe from XSS?
The answer is not always. If the app is built using native Android or iPhone components, classic XSS usually cannot execute because the app treats user content as plain text. But many modern apps don't display everything natively. Instead, they use something called a web view, essentially a mini web browser embedded inside the app. Think about shopping apps, banking apps, food delivery apps, or airline apps. Sections like product descriptions, support pages, offers, blogs, and FAQs are often loaded as web pages. If one of those pages contains an XSS vulnerability, the malicious JavaScript can execute inside that web view just as it would in a regular browser. So remember this. XSS isn't limited to websites you open in Chrome or Safari. If a mobile app displays vulnerable web content, it can also be affected. Fortunately, developers have powerful defenses. Validate all user input. Escape HTML before displaying it. Use Content Security Policy (CSP). Sanitize rich text content. Avoid unsafe JavaScript functions like inner HTML when not necessary. Modern frameworks also include protections, but developers still need to use them correctly. As a user, keep your browser updated. Avoid clicking suspicious links. Use multi-factor authentication. Log out from sensitive accounts. Be cautious on websites that allow public comments or user-generated content. Remember, a trusted website isn't always a safe website, especially if it fails to protect user input. Today you learned how a website can unknowingly execute a hacker's code inside your browser. But here's something even more shocking. What if a hacker doesn't need to trick your browser at all? What if they can talk directly to the database and steal millions of records with a single command? That's exactly what we'll uncover in the next episode. SQL Injection, the attack that changed cybersecurity forever. If you enjoyed this video, subscribe to The Chauhan Explains. Until next time, stay curious, stay secure.